Today's video, I would like to introduce you a very nice problem. Is coming from the Bulgarian Mathematics Olympiad, edition 1986. Here is the following information. Find all n as a natural number, satisfy this following equation. So we have 3 to the n plus 88 must be a perfect square. So we are going to determine the appropriate value of n in order to have the whole thing is a perfect square. Okay? Before we proceed to the solution, I would like to remind you, do not forget to support the channel. Now let's jump into this one. So we say in this term 3 to the n plus 88 is a perfect square, is going to be written on this form, x squared. So now if you take a look at both sides of this equation, this left hand of this equation is odd because they have the term is odd, this one is even, is going to give us odd. Okay, so this one, it's very famous module. This one is very famous. This one is a congruent to 1 mod 4. If I'm going to reduce both sides, if I'm going to reduce this one to the mod 4, we are not going to prove it because it's very common. So you take in the integer and square it. Always you get a remainder 0 or 1. If this one is a even, is arithmetically is going to give us 0 as a remainder when you divide it by number 4. If it is a odd, it's going to give us a number 1 as a remainder. Okay, so it's clear now. Since we are reducing the right hand side of this equation to the mod 4, we need to reduce the left hand side of this equation too. Okay, so this one is clearly is giving us minus 1 all to the n plus 0 is a congruent to 1 is a congruent to x squared is a congruent to 1 mod 4. It's very clear. So this one is very clear because we have 4 minus 3. 3 will be 0. I will be left with minus n to the n. So now we are going to make a nice comparison between the left hand side and the right side. So in order to have this statement true to get number 1 here, so n must be even. N is a even. So if n is a even, let's set n equals to m. I'm simply going to take this value of n and insert it back into the original equation. I get here the following. I get 3 to the 2m plus 88, which equals x squared. So the next thing up, I'm going to move over this term to over the right, leave 88 to the left side. So I get the following. I get x minus 3 to the m factor x plus 3 to the m, which equals 88. So what I have done here, I just moved this term to the right and I get the difference of the squares and factor out that, it gives us this one. Okay, it will factorized is given as an even number. So it's very clear here. So the GCD of these two terms is bigger or equal to number 2 because we get this we get this term is an even, this one also is an even because we get x is an odd. Adding this odd number, adding this odd integer is given as even. Also, if you subtract odd from odd, is going to give us even. So which means I'm going to take only the even values from the right hand side of this equation because we have known values at the right hand side of this equation. And also this one is going to be factorized as 2 is multiplied by 44 or 4 is multiplied by 22. So this is the only two possibilities that we have because we get even must take even. Okay, so the small term is going to take the small value, big term is going to take the big value. So we'll have two possibilities. Let's transfer this one into the equation system. I get x minus 3 to the m. First possibility, I'm going to take this one as a number 2. The second one is going to take 44. So for the second equation system, I get x minus 3 to the m. The other one is going to take number 4. The second equation is going to take 22. Simply going to solve each equation here. This equation minus this equation, I get rid of x because we don't need x here because x is unknown value. Okay, so which means I get 2 times 3 to the m equals 44 minus 2, which is 20. I'm simply going to divide both sides by number 2. I get 3 to the m, which equals 11. This is it's impossible because I get a power of 3, 11, which is impossible. So let's move on to the second equation. Second equation, I'm going to do the same thing here. 2 times 3 to the m, which equals 22 minus 4, which is 18. I'm simply going to divide both sides by number 2 here. I get 3 to the m equals 9. Is the same as 3 squared. So I get the value of m. So I'm going to correct a little mistake here, because 44 minus 2 is given as 42, not 22. So I get here 42. Dividing both sides by number 2 is given as 21. So 21 is the same as 3 is multiplied by 7. So simplifying one of the 3 from here, I get 3 to the m minus 1, which equals 7. Okay, it's clearly we have no solution for this. It's still clearly we have no solution for this one, because we get the left hand side of this equation a power of 3, but the right hand side of this equation is not a power of 3. Okay, so it's clearly this is not solution. So the only solution that we found is m equals 2, because the exponent of this one is number 2. For m equals 2, we found n equals 4 by replacing the value of m into this one here. So now we get only one solution, which is n equals 4. So I have done this problem. Thank you for watching. I will see you next video. Bye.